I welcome you all in this NPTEL online certification course on mechatronics. Today we are going to talk about the fault finding. In a mechatronic system, actually you see that it is very important that in case of certain fault we are able to identify the faults, okay, at what place the fault has occurred. Okay. So, and then we could take the remedial action. Okay. So, the finding of fault, a knowledge about the finding of the fault is essential from the maintenance point of view, that is the maintenance of a mechatronic system. So, fault detection may be needed in measurement unit or control unit or data communication system. Okay. And for details of the fault finding check, it is always advised to go with the manufacturer manuals instructions, okay, and that actually always helps in checking for the required fault. There are a number of techniques that can be used to detect faults, and these are say replication checks, expected value checks, timing checks, reversal checks, parity and error coding checks, and diagnostic checks. Now, let us look at the first one, the replication checks. The replication check involved duplicating or replicating an activity and comparing the result. In the absence of faults, it is assumed that the result should be same. Okay. So, if you are duplicating something, okay, so if there is no fault, the result is going to be same. Okay. But the question is that this could be an expensive option, okay, because you have to replicate it. Okay. So, that is how it is. Next way is that the expected value check. Okay. Usually for the software errors we go for this type of check. Okay. So, software errors are commonly detected by checking whether an expected value is obtained when a specific numerical input is used. Okay. It is expected value, if not obtained, then naturally we say that the system has got a fault. The next way is by the timing checks. Okay. This involves the use of timing check that some function has been carried out within a specified time. Okay. These checks are commonly referred to as the watchdog timers. Then we have the reversal check, okay, where there is a direct relationship between the input and output values. The values of the output can be taken and the input which should have caused it computed, okay, and this can then be compared with the actual input, and this type of check is what is called as the reversal check. Then next is the parity and error coding check. Okay. So, this form of checking is commonly used for detecting memory and data transmission errors. Okay. So, to detect whether data has been corrupted, a parity bit is added to the transmitted data word actually. Okay. And the parity bit is chosen to be making the result number of ones in the group either odd, which we call it as the odd parity, or it could be even, which we call as the even parity. Okay. So, if odd parity, then the word can be checked after transmission to see if it is still odd. Okay. And if it is not odd, then we can say that the data transmission error has occurred. Then we have the diagnostic checks. Okay. So, diagnostic checks are used to test the behavior of a component in a system. Okay. So, input are applied to a component and the output is compared with those which should occur. Okay. So, this is how we do the diagnostic check. Now, let us look at the watchdog timer. A watchdog timer is basically a timer that the system must reset before it times out. Okay. And if the timer is not reset in time, then an error is assumed to have occurred. Okay. I could give an example from the PLC, that is a PLC with a watchdog timer for an operation involving the movement of a piston in a cylinder. Okay. And this is how it could be represented using the ladder diagram. So, you have say start. So, a cylinder is moving plus, okay, and then if this is plus and this is say another one, another cylinder movement, then we can have a timer, and if from this timer we could have a alarm. Okay. Then common hardware faults. Okay. The following are some of the commonly encountered faults that occur with specific type of component and systems. Okay. So, as we are talking about the mechatronic system, so the hardware faults could be there say in your actuators, or it could be there in your sensors, okay, or it could be say in switches and relays, or it could be fault in the hydraulic and pneumatic systems, which we are using either for say actuation purpose, or we are using for say generating some of the control actions. Okay. So, these are the principal hardware type of faults which could be there. Now, let us look at the fault in sensors. Okay. A simple test is to substitute the sensor with a new one, okay, and see the effect on the system, and if the result change, then it is likely that the original sensor was faulty, and if the result do not change, then the fault is elsewhere in the system. It is also possible to check that the voltage or current sources are supplying the correct voltage or currents, as the case may be. Okay. And we could also see that whether my sensor is correctly mounted. Okay. And also the sensor is used under the condition specified by the manufacturer's data sheet. Okay. So, this we have to ensure. Next, let us look at the faulty switches and relays. See, dirt and particles of waste material between the switches contacts are a common source of incorrect functioning of the mechanical switches. A voltmeter used across a switch should indicate the applied voltage when the contacts are open and very nearly 0 when they are closed. Okay. And if a relay fails to operate, then a check can be made on the voltage across the coil, and if correct voltage is present, then the coil continuity can be checked with an ohm meter. Okay. If there is no voltage across the coil, then the fault is likely to be there in the switching transistor used with the relays. Next, let us look at the possible faults in motor. Okay. So, maintenance of both DC or AC motor involves the correct type of lubrication. Okay. So, whatever motor we are using in our mechatronic system, whether it is AC or DC, its maintenance involves the very correct lubrication. Okay. So, with the DC motor, the brushes wear and can require changing until unless you are using the brushless DC motor. Okay. So, in conventional DC motor, you know that for commutation brushes are used. So, we need to periodically change these brushes because they wear. A single phase capacitor start AC motor that is sluggish in starting probably needs a new starting capacitor, okay, in case of AC motor. The 3-phase induction motor require periodic lubrication. So, this is through these steps we can say maintain our motors. Then what are the likely faults in the hydraulic and pneumatic systems? A common cause of faults with hydraulic and pneumatic system is the dirt. A small particle of dirt can damage say seals, okay, which is provided to prevent the leakage. Okay. They can block the orifices and they can cause the valve spool etc. to jam. Okay. Thus, filter should be regularly checked and cleaned, okay, for the dirt. Okay. And components, if you are doing any maintenance activity and you are dismantling the components, okay, so these components should only be dismantled in very clean condition, okay, and oil should be regularly checked and changed. Damage to seals can result in leakage or pressure drop, as I said. The vanes in a vane type of motor are subjected to wear and can then fail to make a good seal with the motor housing, okay, with the result of loss of motor power. The vanes can be replaced. Leaks in hoses pipes and fitting are the other common faults. Next, let us look at the faults in mechatronic systems. Okay. As I said during my course of lecture on this course, you see that the mechatronic system composed of actuators, sensors, okay, signal conditioning unit, your controller, digital controllers and your display unit. Okay. So, once we have seen the issues, the possible issues with say actuator, sensors, okay, then there could also be situations where faults are there in the mechatronic microprocessor system. Okay. So, the typical faults in microprocessor systems are, say you have the chip failure, okay, or say the passive component failure such as say resistors and capacitors, or your circuit is open, or you have the short circuit, or externally some induced interference is there, or there could be the software faults. Okay. So, these are the typical faults in the microprocessor system. Now, what are the fault finding techniques? Okay. So, the fault finding techniques that are used with microprocessor based system, these are the visual inspection, we could have the multimeter, oscilloscope, logic probe, logic pulsar, then current tracer, logic clip, logic comparator, signature analyzer and the logic analyzer. Okay. So, these are the techniques which could be used for finding out the faults in the microprocessor based system. Let us look at these. The visual inspection, just carefully looking at the faulty system may reveal a source of fault. Okay. So, for example, an IC which is loose in its solder or surplus solder bridging tracks on a cracks on a board, that could be there. Okay. So, then we could have a multimeter, it can be used to check for short or open circuit connections and the power supplies. The oscilloscope, oscilloscope is essentially limited to where repetitive signal occur, and the most obvious such signal is the clock signal. Okay. Then we could have the Logic probe. The logic probe is a handheld device shaped like a pen and which can be used to determine the logic level at any point in the circuit to which it is connected. So, this is how the multimeter looks like, this is how the logic probe looks like. Okay, this is the probe tip basically, you have a indicator lamp, you have the TTL or CMOS selector, and then you have the memory clear, and then you have the power connections over here. The current tracer falls to 0 at IC circuit shorts. Okay. So, you have the logic pulsar and you could have the current tracer. The current tracer, as I said, the current tracer is very similar to the logic probe, but it senses pulsing currents in a circuit rather than the voltage level. Okay. The tip of the current tracer is magnetically sensitive and is used to detect the changing magnetic field near a conductor carrying a pulsing current. The current tracer tip is moved along printed circuit tracks to trace out the low impedance path along which the current is flowing. Coming back to the logic pulsar, the logic pulsar is a handheld pulse generator shaped like a pen that is used to inject controlled pulses into the circuit. The pulsar probe tip is pressed against a node in the circuit and the button on the probe pressed to generate a pulse. It is often used with the logic probe to check the functions of the logic gates. The logic clip, a logic clip is a device which clips to an IC and makes contact with each of the IC's pins. Okay. The logic state of each pin is then showed by the LED indicator, there being one for each pin. Next, let us see the logic comparator. The logic comparator tests integrated circuit by comparing them to a good reference integrated circuit. Signature analyzer. With digital system, the procedure of fault finding is more complex than the analog system, since trains of pulses at nodes all look very similar in digital system. Okay. So, to identify whether there is a fault, the sequence of pulses is converted into more readily identifiable form. Okay. Say we could have say 258F, this being termed as the signature. So, this is the logic comparator could work like this. So, this is the circuit being tested and this is your reference circuit. So, you have input pin. So, you give the input to circuit being tested as well as to the reference circuit, and you have the output from the circuit being tested and you have the output from the reference circuit. Okay. And this is provided to the exclusive OR gate here, then you have the pulse stretcher and then you have the indicator drive, and then it gives you the indication. Next, let us see the logic analyzer. The logic analyzer is used to sample and store simultaneously in a first in first out or FIFO memory the logic levels of bus and control signals in a unit under test. The point in the program at which the data capture starts or finishes is selected by the use of a trigger word. Okay. The analyzer compares its trigger word with the incoming data and only starts to store data when the word occurs in the program. Data capture then continues for a predetermined number of clock pulses and then it stops. So, this is how the logic analyzer works. Now, let us look at some of the systematic fault location methods. Okay. There are various methods, say for example, input to output. So, in this method what we do is that we a suitable input signal is injected into the first block of the system, and then the measurements are made in sequence starting from the first block till the output of each block in turn until the faulty block is found. So, this is the input to output. We could also have the output to input. Okay. So, in case of output to input, what is done is that a suitable input signal is injected into the first block of the system, and then measurements are made in sequence starting from the last block. We do it in the reverse way actually, okay, at the output of each block in turn until the faulty block is found. Or other method is the half split. Okay. So, as the name indicates here, a suitable input signal is injected in the first block of the system. The block constituting the systems are split in half, and each half tested to determine in which half the fault lies. Okay. The faulty half is then split into half, and the procedure is repeated until unless we zeros down to the actual block. Now, let us look at the self testing. Okay. Softwares can be used by a microprocessor based system to institute a self test program for correct functioning. Okay. Such programs are often initiated during the startup sequence of a system when it is first switched on. For example, printer, we all know, okay, printer include microprocessor, printer which we use in our offices. Okay. So, such a printer includes microprocessor in their control circuit, and generally the control program stored in the ROM also includes the test routine. Thus, when we switched on the printer, it goes through these test routine and is not ready to receive data until all test indicates the system is fault free. A basic ROM test involves totaling all the data bytes stored in each location in ROM and comparing the sum against that already stored. Okay. And this is also what is called as the checksum test. Okay. And this checksum test many times we also carry out in checking our pen drives. If you are copying some data from a pen drive to another pen drive, we carry out that check. Okay, to see whether the complete data has been copied or not. If there is a difference, then the ROM is faulty, and if they agree, it is considered to be fault free. Emulation. An emulator is a test board which can be used to test a microcontroller and its program. This board contains the microcontroller, the memory chip for the microcontroller to use as data and program memory, an input output port to enable connections to be made with the system under test, and a communication port to enable program code to be downloaded from a computer and the program operation to be monitored. So, here it could be. Okay. So, you have a host computer, you have a monitor terminal over here, and suppose this is the system under test. Okay. So, so the host computer and the monitor terminal, they can get connected through the communication port over here. Okay. So, you have the port replacement unit, there is a memory and there is a MCU. Okay. So, the program code can be written in the host computer and then downloaded through either a serial or parallel link into the memory on the board. The microcontroller then operates as though this program were contained within its own internal memory. This is the evaluation board, say MC68HC11EVB. Okay. So, here basically you can see that this is how we have say port A, D and E connected to MCU, B, C connected to PRU. Okay. You have a latch, you have EEPROM, you have RAM, and then you have the RS 232 drivers and the receivers. Okay. So, you have the host computer over here and you have the terminal over here. Okay. So, the input output connections connector to the plug in connection to the system under test, so that its pin replicate those of MC68 SC11 and is as though the microcontroller was directly connected to the system, and this way we can use evaluation board for testing. So, if you want to read further on this, you can refer the Mechatronics by Bolton. Thank you.